Now we're going to learn how to use our reference angles to help us find exact values of other angles that are not between 0 degrees and 90 degrees. So the first one we're going to look at is cosine of 240 degrees. First of all, I'm going to draw that in standard position to help me determine my reference angle and also to see what quadrant I'm in. If you can get to a point that you can do this without drawing it off, that's perfectly okay. So cosine of 240. So from the positive end of your x-axis, of course positive angle, so we're going to rotate counterclockwise. Your terminal side will end up being somewhere within this area. So from here to here would be the 240. Of course this is 90 degrees, 90 degrees. This portion would be 60 degrees, which that's the portion that ends up being our reference angle from here to here. Okay, so I know that my reference angle is 60 degrees. And the other thing that I need to be aware of is what quadrant I'm in. So we know that we are in quadrant 3. Okay, so going back up here to the problem, what we're going to do is rewrite it. You're going to keep the same trig function, and you're going to replace the angle of 240 degrees with the reference angle of 60. Now I left the space here because we've got to determine positive or negative, and that goes back to the statement that I had given you earlier that said perhaps it might differ in sign. Since you're in the third quadrant, going back to all students take calculus, cosine is going to be negative in your third quadrant. Okay, then from your table of values, cosine 60 degrees is one of those exact values that you're supposed to have memorized, and cosine 60 degrees is 1/2, so here our answer would be negative 1/2. Okay. The second example there that I have is tangent of 135 degrees. So again, if you need to draw it off, 135 degrees is going to terminate in the second quadrant. And that would be with each of these sections having an amount of 45 degrees. So your reference angle is going to be this portion. So we could state that our reference angle is equal to 45 degrees, and we are in the second quadrant. Okay, so going back and rewriting our problem, you would replace 135 with 45 degrees. Since we're in the second quadrant, tangent is going to be negative in the second quadrant. And then from your table of values, you know that tangent 45 degrees is 1. So in this case, your exact value, your answer that you're coming up with is going to be negative 1. Okay, the next one that we're going to look at is going to be tangent of 510 degrees. So the only thing different is just the fact that this is more than one rotation. But again, if you want to draw it in standard position, you're going to have to rotate all the way around, which is 360 degrees. Now if you do the 510 minus 360, that gives you 150 degrees. So at this point it's just like you're drawing 150 degrees off. So your terminal side would fall somewhere within this region. Okay, so this would be the portion that would be your reference angle, and that amount, like this amount, we know is 60 degrees, so this region is 30 degrees. That's going to be your reference angle. So reference angle is 30 degrees, and we are in the second quadrant. Okay, so going back and rewriting our problem, we'll replace the 510 degrees with 30 degrees. And tangent's going to be negative in the second quadrant. So from your table of values, we know that tangent of 30 degrees is 1 over square root 3. And of course, the second quadrant causes that value to be negative. Okay, next, a couple of problems that I'm going to look at here, though, are going to be things other than sine, cosine, and tangent. So you have to handle that just a little bit differently. So again, if you draw 315 degrees off, that's going to terminate in the fourth quadrant. Of course, each of these sections would have an amount of 45 degrees. So your reference angle, again, has to be from terminal side to x-axis. That would be this portion. So we know that our reference angle is 45 degrees, and we are in the fourth quadrant. Okay, so I could rewrite this as cosecant of 45 degrees. Now, cosecant in the fourth quadrant is negative. Now, the table of values, of course, that you memorized only has sine, cosine, and tangent. So just here in parentheses, what you're going to recall is going to be sine 45, since sine is the reciprocal of cosecant. Now, there's two different forms that I gave you for sine 45 degrees, so it doesn't matter which of the two that you use. So I'm going to use the 1 over square root 2. Now, I'm just putting it in parentheses because this is just what I've got to recall. But since sine 45 degrees is 1 over square root 2, and I'm wanting cosecant, then I need to find the reciprocal. So the reciprocal of 1 over square root 2 would just be square root 2. Of course, this would make it negative. Okay, the next one is secant of 120 degrees. So again, if I were to draw that off, that's going to terminate in the second quadrant. So from here to here would be 120 degrees. So this portion has 30 degrees in it. This portion has 60 degrees in it. So this is the area that's going to be our reference angle. So I know that my reference angle is 60 degrees, and I'm in the second quadrant. Okay, so rewriting our trig function will still be secant, but I'll replace the 120 degrees with the 60 degrees. And secant is going to be negative in the second quadrant. All right, so again, in parentheses here, of course, the reciprocal of secant is cosine. So you're going to recall cosine 60 degrees, which cosine 60 degrees is 1/2. So then we need to do the reciprocal of 1/2, which would just be 2. But again, that would now be negative since we're in the second quadrant. So the examples that I happened to pick out here that I worked for you all ended up being negative, but they don't have to be. Like for instance, instead of this being secant of 120 degrees, if I had chosen to do cosecant, cosecant would be positive in the second degree, so your answer would just come out to be positive instead of being negative.